Today we will discuss one important topic, that is the Wronxian of functions. Before discussing Wronxian of functions, first we will discuss linearly independent and dependent solutions. Linearly independent and dependent solutions. Now I am taking n solutions for the nth order linear differential equation. Let y1 of x comma y2 of x comma and so on yn of x be n solutions of linear differential equation of order n. Then these solutions are linearly independent if there exist constants. We are taking n corresponding constants, call it as c1 c2 cn, such that the linear combination, that is c1 y1 plus c2 y2 plus up to plus cn yn is equal to 0, implies every constant is 0. c1 equal to 0, c2 equal to 0, up to and so on cn is equal to 0. If the linear combination of n solutions is 0, then each and every constant should be 0. In this case, we say that the solutions y1, y2 up to yn are linearly independent solutions. Now, if y1 of x, y2 of x, y1 of x, y2 of x, and so on, yn of x are linearly independent solutions, when they are linearly independent solutions, then the linear combination c1 y1 plus c2 y2 plus up to plus cn yn. Okay, this is the linear combination for n vectors corresponding to n constants c1 c2 cn. Whenever the solutions are linearly independent, then the linear combination is also linearly independent solution. Okay, linearly independent means when the linear combination is 0, each and every scalar or constant should be 0. In this case, we say that the solutions are linearly independent. Now, the n solutions y1 of x comma y2 of x and so on yn of x are said to be linearly dependent. I am writing simply LD, linearly dependent, if there exist constants c1 comma c2 comma up to cn, not all zero, such that the linear combination is 0, that is c1 y1 plus c2 y2 plus up to plus cn yn is equal to 0. That means when the linear combination is 0, but there exists at least one constant ci which is not equal to 0. This c1 c2 cn lo either term, at least one term which is not equal to 0. In this case, we say that the solutions are linearly dependent. Okay, we can write the another definition for linearly dependent. The n solutions y1 of x, y2 of x and so on yn of x are linearly dependent if there exist at least one constant one constant Ci, which is not equal to 0 for 1 less than or equal to I less than or equal to n. Okay, here I lies between 1 and n, such that the linear combination is 0. That is C1y1 plus C2y2 plus up to plus Cn yn is equal to 0. In this case, we say that the solutions are linearly dependent solutions. Okay, if we take I am taking two solutions. For example, y1, let y1 of x, y2 of x be two solutions, be two linearly independent solutions. Linearly dependent solutions for second order linear PD. For second order linear PD, linear differential equation simply. Then we can write by definition there existed at least Ci not equal to 0. Here I lies between 1 and 2, 1 less than or equal to I less than or equal to 2, such that the linear combination C1y1 plus C2y2 is equal to 0. This is the linearly dependent of two vectors. Now in this case, either C1 is not equal to 0 or C2 not equal to 0. If C1 is not equal to 0 in this case, if C1 is not equal to 0, this linear combination can be written as y1 is equal to minus C2 by C1 into y2. That means y1 is the linear combination of y2. That means one solution y1 is the linear combination of another solution. That means I am writing here, then y1 is the linear combination of y2. In other words, in case C2 is not equal to 0, then this linear combination can be written as y2 is equal to minus C1 by C2 into y1. In this case, this is nothing but a scalar. The denominator is not equal to 0 means this fraction will define. So it is a scalar. Y2 is the linear combination of y1. Then we say that y2 is the linear combination of y1. Okay, that means if two vectors, if two solutions are linearly dependent, then one solution is the linear combination of another. Okay, we can conclude that here y1 is the linear combination of y2. In this case, y2 is the linear combination of y1. So we can conclude that if two solutions are linearly dependent, then one solution is the linear combination of another. This is an important point. When two solutions are linearly dependent, then we say that one solution is the linear combination of another solution. Now I am taking one example here. For x lies between, that means minus infinity less than x less than infinity. That means x belongs to open interval minus infinity comma plus infinity. This is nothing but set of real numbers. Then the functions, I am taking the functions are polynomials. Functions 1 comma x square comma up to and so on xn are linearly independent. Okay, 1x x square up to x power n. These functions are linearly independent. We can observe here. We can see the procedure. As per procedure, this is nothing but y1. This is y2. This is y3 up to yn. So first we have to consider. Let us consider the linear combination as 0. That is C1 into 1 plus C2 into x plus C3 into x square plus up to plus C. I am taking from C0. This is C0. This is C1 and this is C2. C2 up to and so on Cn x power n is equal to 0. First of all, we have to take this condition. If all the constants C0, C1 up to Cn are 0, in this case we say that the solutions 1 comma x square up to x power n are linearly independent. So we can write this as C0 plus C1 x plus this is C1 C1x plus this C2 x square plus up to plus Cn x power n is equal to 0 can be written as 0 plus some 0 into x plus 0 into x square plus up to plus 0 into x power n. Okay, we can write 0 as the linear combination of 1x x square up to x power n. Now equating the corresponding coefficients of x. So we get C0 is equal to 0, C1 is 0, C2 0, up to and so on Cn is equal to 0. So here we are taking the linear combination is 0. When we are taking linear combination 0, then all the constants are 0. So they said 1 comma are the solutions. Simply you can write the functions 1 comma x square comma up to x power n are linearly independent in the interval, or simply I am writing on R, the set of real numbers. Okay, these are the definitions for linearly independent and dependent solutions. Now once again I am repeating the definitions here. When n solutions y1 y2 up to yn are said to be linearly dependent if the linear combination is 0, c1 y1 plus c2 y2 plus up to plus cn yn equal to 0, then all the scalars, all the constants c1 c2 up to cn are 0. In this case we say that the solutions are linearly independent solutions. And whenever y1 y2 up to yn are linearly independent solutions, then the linear combination c1 y1 plus c2 y2 plus up to plus cn yn is also linearly independent solution. This is also linearly independent solution. Now we see the definition of linearly dependent. The n solutions of a nth order linear differential equation y1 y2 up to yn are said to be linearly dependent if there exist constants c1 c2 up to cn not all 0 at a time, such that c1 y1 plus c2 y2 plus up to plus cn yn equal to 0. That means if the linear combination is 0, there exists at least we can pick up at least one constant which is not equal to 0. That means there exists at least here this is t, at least one constant ci which is not equal to 0. Either it may be c1 or c2 or cn, whatever the term. It may be c3 also. So which is not equal to 0 such that the linear combination is 0. Then we say that the solutions are linearly dependent. And when we take two solutions y1 y2 are linearly dependent, then the linear combination means when y1 y2 are linearly dependent solutions, then one solution is the linear combination of another. That means y1 is the linear combination of y2 or y2 is the linear combination of y1. Okay, you have to remember these are the primary definitions for linearly independent and dependent. And one more thing you have to remember, this is important. 1 x square up to x power n is linearly independent solution. Similarly, we can say that 1 comma x square linearly independent, 1 comma x square comma x cube linearly independent set. Okay, మనం బిగినింగ్ లో కూడా ఆర్డర్ ఫైండ్ అవుట్ చేసేటప్పుడు ఆర్డర్ ఇస్ ఈక్వల్ టు నెంబర్ ఆఫ్ లీనియర్లీ ఇండిపెండెంట్ సొల్యూషన్, నెంబర్ ఆఫ్ లీనియర్లీ ఇండిపెండెంట్ సొల్యూషన్స్ దగ్గర ఒక ప్రాబ్లం చేశాను నేను. 1 కామా ఎక్స్ స్క్వేర్ కామా ఎక్స్ క్యూబ్ అని ఒక ప్రాబ్లం చేసాము. కాబట్టి ఇవి లీనియర్లీ ఇండిపెండెంట్. ఎలా అంటే లీనియర్ కాంబినేషన్ 0 తీసుకున్నాం, ఆల్ ద స్కేలర్స్ ఆల్ ద కాన్స్టెంట్స్ ఆర్ 0 వచ్చాయి, కాబట్టి లీనియర్లీ ఇండిపెండెంట్ సొల్యూషన్స్. ఓకే, నౌ ఐఎమ్ గోయింగ్ అవర్ టాపిక్, దట్ ఈస్ the Wronxian. It is very important topic. The Wronxian of n function. Simply I'm taking the Wronxian. Okay, the Wronxian of n functions y1 of x comma y2 of x comma up to and so on yn of x is denoted by simply w of y1 comma y2 comma and so on yn of x, or it can be sometimes denoted it as w of x. ఇలా కూడా రిప్రజెంట్ చేస్తాం. And is defined to be the determinant. It is defined to be the determinant. The determinant is w of y1 y2 up to and so on yn of x is equal to, we can take the determinant here. First you write the solutions y1 y2 up to and so on yn, and take the first order derivative for this y1 dash y2 dash and so on yn dash and so on. Next we can take second order derivatives y1 double dash y2 double dash and so on yn double dash and so on is to be continued up to n minus 1th derivative y power n minus 1, y1 power n minus 1, y2 power n minus 1 and so on yn power n minus 1. This is n minus 1 represents the n minus 1th derivative. Before the nth derivative is n minus 1th derivative. This is the Wronxian of n solutions, and it is denoted by w of y1 y2 up to and so on yn. Simply we can call it as w of x. Okay, now if we take 3 functions, okay, in place of n functions I am taking 3 functions. The Wronxian of 3 functions y1 comma y2, I am taking y1 of x comma y2 of x, y3 of x is defined as simply I'm writing w of y1 y2 y3 of x, that is equal to, first write the solutions y1 y2 y3, then first order derivative y1 dash y2 dash y3 dash, and the second order derivative y1 double dash y2 double dash y3 double dash. This is the Wronxian of 3 solutions. Okay, ఇక్కడ మనం డిటర్మినెంట్ ఫైండ్ అవుట్ చేయాలండి. డిటర్మినెంట్ ఫైండ్ అవుట్ చేస్తే మనకు వాల్యూ వచ్చేస్తుంది. డిటర్మినెంట్ తెలుసు కదా. Now I am taking the Wronxian of 2 functions. The Wronxian of two functions y1 of x y1 of x comma y2 of x is defined as Wronxian of that y1 comma y2 of x. Okay. Simply I am writing w of x. Okay. That is equal to, you can write y1, y2, y1 dash, y2 dash. Okay. Now we can find the determinant here. That is y1, writing clearly, y1 into y2 dash minus y2 into y1 dash. This is the Wronxian of two functions. Okay, you have to remember this as a formula. Or in other words, for a question adigadante DL lo the Wronxian of y1 of x and y2 of x is simply like options are first the correct option is I am taking y1 comma y2 of x, that is equal to y1 of x into y2 dash of x minus y2 of x into y1 dash of x. Okay, ila manali options here we know that y1 and y2 are functions of x alone. That's why I'm writing y1, y2 dash minus y2, y1 dash. You have to remember this as a formula, very important formula. Okay. Now you have to observe here these y1 and y2. These are the two solutions for the second order linear differential equation. Now we can talk about these solutions for linearly independence and dependence. If the two solutions, I'm taking two solutions y1 of x and y2 of x, of the second order linear differential equation. That is, I am taking a0 of x into y double dash plus a1 of x into y dash plus a2 of x into y is equal to 0. Okay, you have to remember. ఇక్కడ a0, a1, a2 place లో వాడు different values కూడా ఇస్తాడంటే కన్ఫ్యూజ్ కావాల్సిన. This is the second order. Previously y1, y2, y3 are the three solutions for, these are the solutions for third order linear differential equation. Okay, we are generalizing, we are talking about second order linear differential equations. Okay, it is applicable for third order and also for nth order. Okay, so these solutions, two solutions where a0 of x not equal to 0. Okay? Not equal to 0. These solutions are said to be linearly independent or linearly independent if and only Wronxian of y1 comma y2 of x is not equal to 0 for all x belongs to open interval a comma b. The given interval I is the open interval a comma b is the given interval. In this interval, the solutions are linearly independent if and only the Wronxian is not equal to 0. If the Wronxian is equal to 0, then the solutions are linearly dependent. Okay. Now two solutions I am writing here. Two solutions y1 of x and y2 of x of the second order linear differential equation. It is in the form of this. I am writing a0 of x into y double dash plus a1 of x into y dash plus a2 of x into y is equal to 0. Or here we have a0 of x not equal to 0. Okay. are linearly dependent. Linearly dependent if and only if the Wronskian y1 y2 of x is not equal to 0 for some x belongs to open interval a comma b. Here in case
equal to 0, sir.
Yes, it is equal to 0. This is equal to 0. That means here at particular point x naught, for any point in the open interval, in the given interval, at any point, if the Wronskian is equal to 0, then we say that the solutions are linearly dependent solutions. Okay. If we find Wronskian of two functions, either it is 0 or it is not equal to 0. There is no meaning of sign. Not equal to 0 ante ikkada two possibilities untayandi. Not equal to 0 ante ఒకటి ఏంటంటే పాజిటివ్ కావచ్చు. ఫర్ ఎగ్జాంపుల్ Wronskian w of x not equal to 0 అంటే ఇక్కడ పాజిటివ్ w of x పాజిటివ్ వాల్యూ కావచ్చు, లేదంటే నెగటివ్ వాల్యూ కావచ్చు. ఓకే, దీనికి మీనింగ్ ఏం లేదండి. జస్ట్ ఐదర్ ఇట్ ఈస్ నాట్ ఈక్వల్ టు 0 ఆర్ ఇట్ ఈస్ ఈక్వల్ టు 0. ఈక్వల్ టు 0 కావచ్చు, లేదంటే నాట్ ఈక్వల్ టు 0 కావచ్చు. కన్ఫ్యూజ్ కావద్దు. ఇక్కడ మనం ఒక బిట్ కూడా అడిగాడు. ఇక్కడ there is no meaning of signs in the Wronskian. For the Wronskian there is no meaning for signs. ఏంటి ప్లస్ కు మైనస్ కు మీనింగ్ ఏం లేదని చెప్తాడు. ఓకేనా? సో ఐఎమ్ రైటింగ్ వన్ పాయింట్ హియర్. The Wronskian of two solutions of the equation that is second order linear differential equation I'm taking, that is a0 of x into y double dash plus a1 of x into y dash plus a2 of x into y is equal to 0, where a naught of x every time you have to remember it is not equal to 0, and for x belongs to open interval a comma b is either 0, either in detail I am writing identically 0 or never 0 on open interval AB. Either it may be 0 or not equal to 0. There is no meaning of signs. Okay. Now I'm taking, if the two solutions are linearly independent. For example, y1, y2. If y1 of x and y2 of x be any two linearly independent solutions. Solutions for the homogeneous linear differential equation of order n. Homogeneous linear differential equation, okay, of order 2, second order homogeneous linear equation. Now for homogeneous linear equations, these solutions either linearly independent or linearly dependent. In this case, we can write the solution as c1 y1 plus c2 y2. This is a solution for homogeneous. For non-homogeneous, there is another solution. It is called it as complementary function. Simply I am taking CF. Okay. For homogeneous, for non-homogeneous, we need to find another solution, that is called a particular solution. This is the particular solution, and we can observe here the particular solution not contains contains arbitrary constant. Arbitrary constant. Okay, polytechnic lo ide question adigandi. When the solution y1 when y1 y2 are any two linearly independent solutions for the non-homogeneous, it is non-homogeneous linear differential equation of order n of order 2, that is y double dash plus p of x into y dash plus q of x into y is equal to r of x. This is non-homogeneous. That means here r of x is not equal to 0. In this case, the particular solution not contains the arbitrary constant. Particular solution has no arbitrary constant. In the previous problems, we can also observe the particular solution has no arbitrary constant. Then the general solution, is simply I'm writing is y0 plus c1 y1 plus c2 y2, and this part c1 and I'm writing here c1 y1 plus c2 y2 is complementary function. This is complementary function as to arbitrary constant, and writing y0. This is y0. Y0 is the particular solution, and this particular solution has no arbitrary constant, not containing arbitrary. I'm writing not containing arbitrary constant. Okay, you have to containing arbitrary constants. Okay, you have to observe this point. Okay, now if we take the y1 and y2 are two solutions of a linear differential equation, second order linear differential equation. In other words, we can take I'm taking p1 of x and p2 of x be real or complex. Real valued functions are complex valued functions defined and continuous on an interval I, any interval I. Then and we are taking pi1 comma pi2 be linearly independent solutions. Solutions of second order linear differential equation. Of second order linear differential equation, I'm taking y double dash plus p1 of x into y dash plus p2 of x into y is equal to 0. This is the second order here, where p1 of x and p2 of x are real valued functions or complex valued functions. Then existing R9. That means pi1, pi2 are linearly independent solutions for this differential equation existing on I, containing a point x0. That means x0 be any point in the interval I. Then we can write Wronskian of pi1 comma pi2 of x. Function of pi1 comma pi2 of x is equal to exponential of exponential of minus integral x naught to x. These are the limits for x. P1 of x into dx into Wronskian of phi1 comma phi2 of x naught. This is the formula, and this formula is known as Abel's formula or Abel's formula. Simply I am writing the Abel's formula. We are taking, simply you have to remember phi1, phi2 are two linearly independent solutions for the second order linear PDE in the form of y double dash plus p1 of x into y dash plus p2 of x into y equal to 0. In place p1, p2, we can take another functions also, alpha 1, alpha 2, or alpha x, beta x like that. In this case, the Abel's formula is Wronskian of phi1 comma phi2 of x is equal to exponential of integral x naught to x p1 of x into dx into Wronskian of phi1 comma phi2 of x naught. Okay. Now we can take Wronskian formula for n solutions. Same and ikkada phi1 phi2 place lo emostayi ikkada manaku phi1 comma phi2 comma up to and so on pi n of x is equal to exponential of minus integral x naught to x p1 of x into dx Wronskian of phi1 phi2 up to and so on pi n of x naught. Okay, this is the generalized formula. Okay, I am taking for our convenient, we are taking two solutions. Okay, now the consequence of Abel's formula. Abel's formula that n solutions phi1 comma phi2 comma dash dash phi n are linearly independent if and only the Wronskian of phi1 phi2 up to and so on pi n of x is not equal to 0 for or simply on I. Simply I am taking on the interval I. Okay, this is the Wronskian of two functions by n functions. We know the formula for two functions, Wronskian of y1 y2 is not equal to 0. In this case, we can say that the y1 y2 are linearly independent. For n solutions also, the Wronskian is not equal to 0. In this case, we say that the n solutions are linearly independent solutions. Okay. Now I am taking one application of Abel's theorem or Abel's formula. This is from GATE 2013 lo adigadandi. Application different adigadu, but we have to remember this application also. Okay. Let Wronskian of y1 comma y2 be the Wronskian of two linearly independent solutions. Y1 and y2 or y1 comma y2 of the second order linear. Simply I am writing of the equation y double dash plus p of x into y dash plus q of x into y is equal to 0. Okay. Now the product Wronskian of y1 comma y2 p of x equals అని మనకు different options ఇచ్చాడు. I am writing the options also here. Okay, it is GATE 2013 question. You can see in the question paper also. Y2 y1 double dash minus y1 y2 double dash, and the B option y1 y2 dash and y2 y1 dash, and the C option y1 dash y2 double dash minus y2 dash y1 double dash, and the D option y2 dash y1 dash minus y1 double dash y2 double dash. These are the options. As we know that you have to observe the solutions y1 and y2 are linearly independent solutions. That means the Wronskian is not equal to 0. Okay, I'm taking the solution for this. It is GATE question, so we take some time also. We can remember after getting the formula, we can remember this as a formula. Okay, let y1 comma y2 are linearly independent solutions. Linearly independent solutions. Then linearly independent solutions of this equation. Y double dash plus P of x into y dash plus Q of x into y is equal to 0. That means y1 satisfies this equation and also y2. Then in this case, we can write that y1 double dash plus P of x into y1 dash, this is y1 double dash plus P of x into y1 dash plus Q of x into y1 is equal to 0. Call it as equation number 1. And also for y2, that is y2 double dash plus P of x into y2 dash plus Q of x into y2 is equal to 0. Because y1 and y2 are two solutions for the second order linear differential equation. Now solve these two equations. For solving these two equations, I'm taking multiplying, that means equation 1 with y2 and subtracting equation 2 and multiplying with y1. We are doing this operation. So while doing this operation, we'll get y1 double dash y2 plus P of x into y1 dash y2 plus Q of x into y1 y2 is equal to 0. It takes time, even though we can do. And we are multiplying y1 for the second equation. That is y2 double dash y1 plus P of x into y2 dash into y1 plus Q of x into y1 into y2 is equal to 0. Now we are subtracting these two. So you can change the sign here for every term. Minus, these two terms are same, so cancel. So we can take here y1 double dash y2 minus y2 double dash y1 is the first term, plus in these two terms we can take P of x as common, remaining y1 dash y2 minus y2 dash y1 is equal to 0. Okay, so we can write this as y1 double dash y2 minus y2 double dash y1 is equal to minus P of x into this term y1 dash y2 dash y1, as we know that by definition of Wronskian Wronskian of y1 y2 equal to y1 y2 dash minus y2 y1 dash y1 y2 dash. So we can take this as y1 double dash y2 double dash y1, no need of bracket here. This is equal to, we can write p of x into this as we are multiplying with minus y1 y2 dash minus y2 y1 dash. This is same. I am writing, no need to write again and again. Erasing this. Here we can write this as p of x into, this is nothing but by definition of Wronskian of y1 comma y2 of x. So the product Wronskian of y1 comma y2 of x into p of x. This is the product that is equal to what? y1 double dash y2 minus y2 double dash y1. This is the product. Okay, you have to remember this as a formula. y1 double dash y2 minus y2 double dash y1. Okay, so our right option is, first option is the right option. Okay, one more thing we can remember, one more thing here. From this we can write Wronskian of y1 comma y2 of x into p of x is equal to, I am writing same formula, y1 double dash y2 minus y2 double dash y1. From this we can write p of x value. Okay, or we can write directly, I am writing p of x directly, that is p of x is equal to, from this we can write p of x is equal to, the numerator is this y1 double dash y2 double dash y1 by Wronskian of y1 y2 of x, or simply Wronskian of y1 y2. Now we can write the formula for Wronskian here, that is p of x is equal to y1 double dash y2 minus y2 double dash y1 by Wronskian of y1 y2 is nothing but y1 y2 dash minus y2 y1 dash. This is also formula, and to remember this p of x is the coefficient of y dash. Okay, for the equation y dash equation. Ikkada p of x ఉండాలని ఏం లేదు, alpha x ఉండొచ్చు, alpha 1 ఉండొచ్చు, a1 ఉండొచ్చు, b1 ఉండొచ్చు, ఏదైనా వాల్యూ ఉండొచ్చు. Okay, these are the concepts of Wronskian of functions. Okay, now I am taking some problems related to Wronskian. First I am taking simple problems. First I am taking one GL problem. GL. The Wronskian of sin x and cos x is, this is nothing but y1, this is y2. Wronskian of y1 y2 is equal to formula y1 y2 dash minus y2 y1 dash. లేదంటే మీరు డిటర్మినెంట్ ఫైండ్ అవుట్ చేసి సింప్లిఫై చేస్తే నో ప్రాబ్లం. y1 is sin x, y2 dash is minus sin x, y2 is cos x, and y1 dash is, that is cos x. This is also cos x. So this is sin square x, this is cos square x. We can take minus common, that is minus of sin square x plus cos square x. So this is equal to minus. So the Wronskian of y1 y2 is equal to the Wronskian of sin x and cos x is equal to minus 1. Okay, that means here you can observe the Wronskian of, I am writing the observation, the Wronskian of cos x comma sin x is equal to -1, which is not equal to 0. Which is not equal to 0 means cos x and sin x, or sin x cos x, whatever the values. Okay, I'm taking sin x cos x. This is sin x cos x not equal to 0. Then sin x and cos x are linearly independent solutions. Sin x and cos x are linearly independent solutions. Okay. Similarly, if we take a Wronskian of sin 2x comma cos 2x, okay, that is nothing but first term as is the రాసుకోవాలి sin 2x, second function ను డెరివేటివ్ చేయాలి -2 sin 2x మైనస్ సేమ్ మైనస్ పెట్టేసి uv డాష్ ప్లస్ vu డాష్ ఫార్ములానే కాకుండా అక్కడ ప్లస్ ఉంటుంది, ఇక్కడ మైనస్ ఉంటుంది, డిఫరెన్స్ అది. Here we can write second term cos 2x as this, sin 2x derivative రాసుకోండి 2 cos 2x. This is equal to, this is minus 2 sin square x, you can take minus 2 common, sin square x, sin square 2x, we can take minus common, plus cos square 2x. This is equal to minus 2. Minus 2 is not equal to 0. So the Wronskian is not equal to 0 means, therefore, sin 2x comma cos 2x are linearly independent solutions. Okay, linearly independent solution. Similarly, we can say that sin 3x cos 3x are also linearly independent solution. These are all also linearly independent solution, but we can take different values for example ax cos ax and this different values ko linearly independent solutions like that. Now I am taking the Wronskian of, if I can observe here, sin x and cos x, sin x and cos x are linearly independent solutions. We know that already, we are మనం చేసాం linearly independent solutions for the second order linear differential equation. For the differential equation y double dash plus y is equal to 0. Y double dash plus y equal to 0. దీనికి auxiliary equation ఏమవుతుంది, m square plus 1 equal to 0, m equal to plus or minus I, y equal to c1 cos x plus c2 sin x. So this is the linear combination. This is linearly independent solution. This is linearly independent solution. The linear combination is also linearly independent solution. Okay, the linear combination of linearly independent solutions is also linearly independent. Now similarly, ikkada sin x cos x solutions of linearly independent solutions of linear differential equation y double dash plus y is equal to 0. So generalize చేస్తున్నాను నేను, generalize చేసేసి రాస్తున్నా sin ax and cos ax are linearly independent solutions for the differential equation y double dash plus a square y is equal to 0. ఇప్పుడు నేను sin 2x cos 2x తీసుకున్నాను అనుకోండి, డిఫరెన్షియల్ ఈక్వేషన్ ఏమవుతుంది, y double dash plus 4y is equal to 0. నెక్స్ట్ sin 3x cos 3x తీసుకున్నాను అనుకోండి, డిఫరెన్షియల్ ఈక్వేషన్ y డబుల్ డాష్ ప్లస్ 9y ఈక్వల్ టు 0 అవుతుంది. ఓకే, యూ హ్యావ్ టు రిమెంబర్ దట్. ఇంకొక ఇంటి కూడా ఇస్తాను నేను. Before taking that hint, I am giving one more problem. It is from JL. The Wronxian of 1 comma x comma x square for minus infinity less than x less than infinity is. That means x is any real number. Okay, complete real line plus infinity minus infinity. In this real line, x is any real number. Okay, it may be positive number, it may be negative number also. Okay, in this interval, the Wronxian, we need to find the Wronxian of 1x square. That is Wronxian of 1 comma x square. The three functions ఉన్నాయి కాబట్టి డిటర్మినెంట్ చేయాలండి. దట్ ఈస్ 1x square. డెరివేటివ్ చేయండి. 1 డెరివేటివ్ 0, ఫస్ట్ టైం డెరివేటివ్ 1, this is 2x, and again derivative 0 derivative 0, 2x 1 derivative 0, 2x derivative 2. This is actually an upper triangular matrix. This is an upper triangular matrix. Determinant is equal to product of diagonal elements. That is equal to 2 not equal to 0. That means the Wronxian is not equal to 0. Therefore, Wronxian of 1x square is not equal to 0 for minus x belongs to open interval minus infinity comma plus infinity. Therefore, the solutions 1 comma x square are linearly independent solutions. Okay, సింపుల్ గా ఇక్కడ లీనియర్లీ ఇండిపెండెంట్ సొల్యూషన్ అనే టాపిక్ చాలా ఇంపార్టెంట్ అండి. అది ఫర్ ఎగ్జాంపుల్ ఎక్స్ క్యూబ్ ఉంది అనుకోండి, దీనికి లీనియర్లీ ఇండిపెండెంట్ డెరివేటివ్స్ తీసుకుంటున్నాం. లీనియర్లీ ఇండిపెండెంట్ డెరివేటివ్స్ లీనియర్లీ ఇండిపెండెంట్ డెరివేటివ్స్ అంటే నేను కంప్లీట్ గా రాస్తాను. ఫర్ ఎక్స్ క్యూబ్ లీనియర్లీ independent derivatives. Okay, క్వశ్చన్ ఎలా అడగడానికి లీనియర్లీ ఇండిపెండెంట్ డెరివేటివ్స్ అంటే దీన్ని డెరివేటివ్ చేయాలండి. ఎక్స్ క్యూబ్ వస్తుంది, ఫస్ట్ ఎక్స్ క్యూబ్ రాసుకోండి. దీన్ని డెరివేటివ్ చేయండి. డెరివేటివ్ చేస్తే 3x square వస్తుంది. మళ్ళీ డెరివేటివ్ చేయండి, 6x వస్తుంది. మళ్ళీ డెరివేటివ్ చేయండి, 6 వస్తుంది. ఓకే, ఈ కాన్స్టెంట్స్ తీసుకోకూడదండి. ఇక్కడ 1 ఉంటుంది, x⁻0 అనమాట. కాబట్టి లీనియర్లీ ఇండిపెండెంట్ డెరివేటివ్స్ ఏవైతే అంటే x⁻0 కామా x⁻1 కామా x square కామా x cube. దీస్ ఆర్ లీనియర్లీ ఇండిపెండెంట్ డెరివేటివ్స్. x⁻0 అంటే 1 వస్తుంది. ఓకే, మీకు స్టార్టింగ్ లో ఒక ప్రాబ్లం చెప్పేటప్పుడు d⁴ y/dx⁴ is equal to 0 లో లీనియర్లీ ఇండిపెండెంట్ సొల్యూషన్స్ అంటే అక్కడ 1 కామా x square కామా x cube లీనియర్లీ ఇండిపెండెంట్ సొల్యూషన్స్ అని అడిగారు. చాలా మంది అడిగారు, సరే ఇది ఎట్లా లీనియర్లీ ఇండిపెండెంట్ అవుతుందని. ఓకే, లీనియర్లీ ఇండిపెండెంట్ డెరివేటివ్స్ ఏంటంటే x cube కు 1 x square x cube. For x square we can write the linearly independent derivatives. This for x square, the linearly independent derivatives are first x square, next x, next 1. These are the linearly independent derivatives. Now for sin x, the linearly independent derivatives, sin x as is the right, cos x sin x డెరివేట్ చేస్తే cos x వస్తుంది. ఇవి లీనియర్లీ ఇండిపెండెంట్ డెరివేటివ్స్. అండ్ cos x ను డెరివేటివ్ చేయండి. ఫస్ట్ cos x రాసుకోండి. cos x ను డెరివేట్ చేస్తే మైనస్ సైన్ ఎక్స్ వస్తుంది, మైనస్ తో మనకు పని లేదు. సైన్ ఎక్స్ అంటే సైన్ ఎక్స్ కు సేమ్ సైన్ ఎక్స్ కాస్ ఎక్స్ కూడా సైన్ ఎక్స్ కాస్ ఎక్స్ ఆర్ ది లీనియర్లీ ఇండిపెండెంట్ డెరివేటివ్స్. నా e to the power of x తీసుకున్నాను. ఓకే, ఇప్పుడు క్వశ్చన్ ఇక్కడ అడిగాడు ది లీనియర్లీ ఇండిపెండెంట్ డెరివేటివ్స్ ఆఫ్ పాలిటెక్నిక్ లో అడిగాడు. ది లీనియర్లీ ఇండిపెండెంట్ డెరివేటివ్స్ ఆఫ్ ఈ పవర్ ఎక్స్ అన్నాడు. ఈ పవర్ ఎక్స్ అంటే ఈ పవర్ ఎక్స్ డెరివేటివ్ చేస్తే ఈ పవర్ ఎక్స్ వస్తుంది, ఈ పవర్ ఎక్స్ వస్తుంది. దిస్ ఈస్ ద లీనియర్లీ ఇండిపెండెంట్ డెరివేటివ్. దిస్ ఈస్ లీనియర్లీ ఇండిపెండెంట్ డెరివేటివ్. ఓకే, ఫర్ సైన్ ఎక్స్ కు కాస్ ఎక్స్ సైన్ ఎక్స్ ఎందుకు రాసామంటే డెరివేటివ్ చేస్తాం. సైన్ ఎక్స్ డెరివేట్ చేస్తే కాస్ ఎక్స్ వచ్చింది, మళ్ళీ కాస్ ఎక్స్ డెరివేట్ చేస్తే సైన్ ఎక్స్ వస్తుంది. కాబట్టి ఈ రెండే లీనియర్లీ ఇండిపెండెంట్ డెరివేటివ్స్. ఈ పవర్ ఎక్స్ డెరివేటివ్ ఈ పవర్ ఎక్స్, మళ్ళీ ఈ పవర్ ఎక్స్, మళ్ళీ ఈ పవర్ ఎక్స్ అండ్ సో ఆన్. ఇలా అన్నిటిని ఒకటే సెట్ లాగా తీసుకుంటాం. ఒక సెట్ లో అంటే సెట్ లో ఎలిమెంట్స్ రిపీట్ కావు కాబట్టి ఓన్లీ ఈ పవర్ ఎక్స్ ఇస్ ద లీనియర్లీ ఇండిపెండెంట్ సొల్యూషన్. సారీ, లీనియర్లీ ఇండిపెండెంట్ డెరివేటివ్. ఓకే, now we can yes
సార్ ఎక్స్క్యూజ్ మీ సార్, ఒకసారి ఎక్స్ క్యూబ్ లీనియర్లీ ఇండిపెండెంట్ వేరియబుల్స్ ఒకసారి ఎక్స్ప్లెయిన్ చేయగలుగుతారా?
ఎక్స్ క్యూబ్ నండి, ఎక్స్ క్యూబ్ ను డెరివేటివ్ చేస్తాం. 3x² డెరివేటివ్ చేయండి 6x వస్తుంది, 6x డెరివేటివ్ చేయండి 6 వస్తుంది. 6 is nothing but 6 into x power 0. ఇందులో ఓన్లీ వేరియబుల్స్ తీసుకోవాలండి. x క్యూబ్ x power 0, x power 1, x power 2, x power 3 అదే రాసాం కదా. x క్యూబ్ x² x power 1 అంటే x ఉంది, దిస్ ఈస్ x power 0 అంటే 1. ఓకే అమ్మా.
సార్ ఎక్స్ క్యూబ్ డెరివేటివ్ ఎక్స్ క్యూబ్ కూడా రాసుకోవాలా సార్?
ఎక్స్ క్యూబ్ కూడా రాయాలి. ఫస్ట్ టర్మ్ ఎక్స్ క్యూబ్ అవుతుంది, ఫస్ట్ అది మెన్షన్ చేయాలి కంపల్సరీ. దిస్ ఇస్ నాట్ ఎక్స్క్లూడెడ్. ఓకే, ఇట్ షుడ్ బి.
ఓకే సార్, థ్యాంక్ యూ.
ఓకే, నౌ ఐ యామ్ టేకింగ్ అనదర్ ప్రాబ్లం.
ఎక్స్క్యూజ్ మీ సార్, ముందు సైన్స్ తీసుకోకూడదా సార్? మైనస్
మీ సైన్స్ తీసుకోకూడదు, కాన్స్టెంట్స్ కూడా తీసుకోకూడదండి. కాన్స్టెంట్స్ ఏమైనా ఉండొచ్చు, సైన్స్ ఏమైనా ఉండొచ్చు, వాటితో మనకు పని లేదు. Just we are taking the variables. That means we are taking only functions. Only functions. Okay, no?
Okay, sir. Thank you.
I'm taking another problem from set. This is set question. Let y1 of x and y2 of x be two solutions. Be two solutions of y double dash plus 3x into y dash plus e to the power of minus x square into y is equal to 0, satisfying y1 of 0 equal to 0, y1 dash of 0 is equal to -1, y2 of 0 is equal to 1, y2 dash of 0 is equal to -1. Then the Wronskian of y1 comma y2 of x of y1 x and y2 of x at x is equal to 1. This is the problem. Okay, now we are given, I am taking the solution. First we are given the y1 y2 values at origin at 0 we are given. Okay, we need to find the Wronskian at x is equal to 1 point దగ్గర find out. Okay, so first I am finding the Wronskian at 0. That means Wronskian of y1 comma y2 of 0 we are finding. That is equal to formula y1 dash y2 dash. at the point 0, y1 dash of 0, y1 of 0, y1 dash of 0, y2 dash of 0, y2 of 0. That is equal to y1 of 0 is 0, y2 of 0 is 1, y1 dash of 0, that is minus 1, and y2 dash of 0 is minus 1. So this value is 1 determined. Okay, 0 minus of minus plus 1. This is the Wronskian of y1, y2 at 0 only. But we have to find ఇక్కడ మీకు ఆప్షన్స్ కూడా ఇస్తాను నేను కన్ఫ్యూజ్ కాకుండా ఉండడానికి ఆప్షన్స్ ఇందులో రాస్తాను బాక్స్ ఆప్షన్ ఏ ఈ ఆప్షన్ బి e power minus 1, option C minus e, option D minus e power minus 1. These are the options. So now we need to find the Wronskian at the point 1. That is equal to, we can use Abel's formula here. Abel's formula. The Abel's formula is Wronskian of y1, y2 of x is equal to exponential of integral x naught to x minus here minus p1 of x into dx, and Wronskian of y1 comma y2 of at 0. Here x naught is initial value is 0, x is terminal value, that is 1 we are given. The Wronskian of y1, y2 of 0. You can write it as. Okay, this is the formula we are changing. Abel's formula no vidhanga rasam. Okay, so this is equal to exponential of minus integral 0 to 1 p1 of x. This is the coefficient of first derivative, y dash coefficient, that is 3 entandi
3x sir.
Okay, no, I'm sorry, it is 3x square. Question of 3x square. So this is 3x square into dx, and the Wronskian of y1, y2 of 0 is 1 and మనం find out చేసాం ఇక్కడ 1 వచ్చేసి. Now this is equal to exponential of minus 3x square integration x cube అని 3 cancel అయిపోతుంది, x limits 0 to 1 1 ఇలానే ఉంటుంది. Exponential of upper limit minus 1, lower limit is 0. So exponential means e power, that is e power minus 1. E power minus 1 is the right option. That is B option is the right option. Okay. Today I will stop here. If you have any question, you can ask. Yes.
Sir, can you explain one